Hello, dear student. This will be our last lecture on trigonometry, and in this video, we are going to start from the trigonometric identities of sum of two angles. We are going to start from sine identity. If we have sum of two angles, alpha and beta, and if we take sine function of this sum, we will have sine alpha cos beta plus cos alpha sine beta. And similarly, if we take cos function of this sum, we will have cos alpha cos beta minus sine alpha and sine beta. Now we can make a general rule for memorization of these identities, that in case of sine function we will have opposite functions, that with sine function we will have cos function, and with cos function we will have sine function. Functions will be opposite but sign will remain same. In case if we have positive sign on left hand side, we will have positive sign on right hand side. But in case of cos function, we will not have opposite function, we will have same functions. Like you can see that cos function is coming with cos function and sine function is coming with sine function, but we have opposite signs. We can see here that here we have positive sign and here we will have negative sign. So we can write sine alpha minus beta will be equal to sine alpha cos beta minus cos alpha sine beta, and cos alpha minus beta will be equal to cos alpha cos beta plus sine alpha sine beta. Again, we can see that in case of sine function we have opposite functions, that sine is coming with cos and cos is coming with sine, but sine will remain same. If we have negative sign here and we will also have negative sign here. Similarly, in cos function we don't have opposite functions but we have opposite signs. Like we have negative sign here, we will have plus sign here. Signs are opposite but functions are same. Like cos is coming is with cos and sine is coming with sine. Now similarly we can have tangent function of sum of two angles, sum or difference of two angles, that will be equal to tangent alpha plus minus tangent beta divided by 1 minus plus tangent alpha into tangent beta. If we have plus sign here, we will also have plus sign here, but if we have plus sign here, we will have negative sign here. These two signs will be opposite. If we have plus here, here we will have minus, and if we have minus here, we will have plus here. In case of tangent alpha plus beta, we will have tangent alpha plus tangent beta divided by 1 minus tangent alpha into tangent beta. But if we expand tangent alpha minus beta, that will be equal to tangent alpha minus tangent beta divided by 1 plus tangent alpha into tangent beta. So this was some basic formulas for trigonometry, and we can deduce double angle identities using these formulas. For example, if we want to find the identity for sine 2 alpha, it means it is equal to sine alpha plus alpha, because 2 alpha is equal to alpha plus alpha. We can use this formula. We will have sine alpha cos alpha plus cos alpha into sine alpha. If we put alpha and alpha over here in case of alpha and beta, so that will be equal to 2 sine alpha into cos alpha. So sine 2 alpha will be equal to 2 sine alpha into cos alpha. We can have this formula. This is called double angle formula because we have double angle here. Similarly, we can find the cos identity of double angle if we use this formula. If we put alpha over here and alpha over here, that will be equal to cos square alpha minus sine square alpha. This is double angle identity for cos function. Now up next we have very important identities. That identities will be called half angle identities. We will start from cos function. Cos alpha over 2. Alpha over 2 is half angle. It will be equal to 1 plus cos alpha over 2, and sine alpha over 2 will be equal to square root of 1 minus cos alpha over 2. These two identities are called half angle identities, and we can also derive half angle identity of tangent if we divide these two functions. If we divide this vector over this vector, we can have half angle identity for tangent function. Now if we double this angle, this thing is very important, that if we double this angle alpha over 2, we will have alpha. If we multiply this by 2, we will have alpha. So if we are doubling this angle on right hand side, we will have to double the angle on right hand side, so that will become 1 plus cos 2 alpha over 2. So similarly, if we double this angle, if we multiply this angle alpha over 2 with 2, we will have alpha. Here we will have alpha, and we will have to double this angle, so that will become 1 minus cos 2 alpha over 2. And we can also do same thing over here, that if we divide this angle on right hand side over 2, if we divide this angle over 2, we will have alpha here. We will have to divide the angles on right hand side, so that will become 2 into sine alpha over 2 into cos alpha over 2, and we can do same thing over here. Now we are going to move towards next step. It is basically the modification of a function which will help in the solution of any trigonometric equation. We can write any trigonometric expression into this form: r into sine x plus theta. We can write any trigonometric function into this form. For example, if we have a function 3 sine x plus 2 cos x, and we need to convert this expression into this expression. How will we convert this? If we expand this, in our last step we have seen the sine function of sum of two angles, so that will be equal to sine x cos theta plus cos x into sine theta. We will have r here because we need to multiply r with this. So if we compare these two equations, this vector will be equal to this vector, and this vector will be equal to this vector. And if we compare this function with this function, sine x will be cancelled with sine x, so r cos theta will be equal to 3. And similarly, if we compare this function with this function, we will have r sine theta will be equal to 2. Now we need to evaluate two values. We need to find r and theta using these two equations. If we divide these two equations, we will have r sine theta over r cos theta will be equal to 2 over 3. So that will be, r will be cancelled with r, sine over cos will be equal to tangent theta. So theta will be equal to tangent inverse of 2 over 3, and this is basically equal to 34 degrees. This will be equal to 34 degrees. And we can also find r using these two equations by adding squares of both equations. That will be equal to r square into sine square theta plus r square into cos square theta will be equal to 2 square is 4 and 3 square is 9. 4 plus 9. We know that sine square theta plus cos square theta is always equal to 1. So in this equation, r will be equal to square root of 13. So this particular function will become this: r, which is equal to square root of 13 into sine x plus 34. So this is basically conversion of this trigonometric expression into another expression, and this is very useful if we want to solve some trigonometric equations. We will see the application of this conversion in our next part. Like we have a question, we will solve a question using this conversion. For example, We have, this is example 1, we have an equation 3 sine x minus 2 cos x is equal to 1. Solve 3 sine x minus 2 cos x is equal to 1. First of all, we will try to solve this by a trigonometric method. We can convert this 3 sine x minus 2 cos x into another form. For example, if we equate this 3 sine x minus 2 cos x is equal to r into sine x minus theta, we will have 3 into sine of x into 2 cos x is equal to r sine x cos theta minus r cos x into sine theta. So we will have, if we compare this with this, we will have r cos theta is equal to 3 and r sine theta will be equal to 2. And using these two equations, we will see that theta is equal to 34 and r is equal to square root of 13. So if we substitute these two values over here, we will see that it will become square root of 13 into sine x minus 34 degree. Now this is basically a conversion of this one function into this function. Now in this case we have just one trigonometric function, which is sine function, so we can solve this equation very easily. If we substitute this modification into this equation, we will have square root of 13 into sine x minus 34 is equal to 1. So that will become x minus 34 will be equal to sine inverse of 1 over square root of 13, and this will be equal to x minus 34 is, if we take sine inverse of 1 over square root of 13, we will have 16.1. And we can see that sine 180 minus theta is always equal to sine theta, because across 180 we will not have any change in functions, it will remain equal to sine theta. And because 180 minus theta is lying in second quadrant, and in second quadrant sine theta is always positive, so we will have sine theta. So we can subtract 16.1 from 180, that will be equal to almost 163 degrees. So we are having these two angles, and this minus 34 will become positive if we take it over here. So finally we will have two angles, 16 plus 34, that will be equal to 50 degree, and 163 plus 34, that will be equal to 197 degrees. So we have two answers. And if we draw in second part, we can also find graphical solution of this equation. This equation is basically equal to y is equal to 3 sine x minus 2 cos x minus 1. This is our equation, and we can draw graph of this equation. We are taking just just four values, four regular values. This is 0 degree, 90, 180, 270 and 360. We are taking just four values. If we substitute 0 in this equation, we know that Sine 0 is always 0, cos 0 is 1, so y will be equal to minus 3. That will be minus 1, minus 2, minus 3, and minus 4, 1, 2. Okay, if we substitute 0 in this equation, sine 0 is 0, cos 0 is 1, so minus 2, minus 1, we will have minus 3 at x is equal to 0. And if we substitute 90, we know that sine 90 is 1 and cos 90 is 0, so 3 minus 1 will be equal to 2. So at 90 degree we will have this value. And if we substitute 180, we will have y is equal to minus 1. And if we substitute 270, we will have minus 4, y will be equal to minus 4. And if we substitute 360, that will be equal to minus 3. So if we join all these coordinates, we will have this graph. Now we can see that here x is almost equal to 50 degree, and at this x is almost equal to 197 degree. If we use graph paper, we will have exact solution, exact graphical solution. We can have exact graphical solution if we use graph paper. So we can see that using trigonometric method, we have two answers, 50 degree and 197 degree of this equation, and using graphical method we have same answers. So in this question we have revised three concepts. We have revised the conversion of this function into this function, and secondly we have revised the solution of trigonometric equation, and we have revised the graphical solution of trigonometric equation. Up next we have a very important question. This will be our final question. After that we are going to wind up this video. This will be our final question. Okay, now let's suppose we have two trigonometric functions. Function 1 is y is equal to 5 cos 2x plus 2, and function 2 is equal to y into cos of x. And we have graphs of these two trigonometric functions like this. This graphical representation is part of the statement of this question. We can have a graphical representation of like this. This is, let's suppose this is function 1 and this is function 2, and this is graph of function 1, and we can have graph of function 2 like this. This is graph of function 2, and we have 2 points. This is point A, this is point B, this is point P, and this is point Q. So basically we have 4 points. Point A and point B are 2 points at which the graph of function 1 is intersecting x-axis. Basically point A and point B are x-intercepts of this equation, graph of this equation, and point P and point Q are basically point of intersections of both graphs, these two graphs. So first of all we need to find point A and point B. This is first part of our solution. We need to find coordinates of point A and point B in first part. We can see that the graph of equation 1 is intersecting at point A and point B at x-axis, and if we need to find x-axis x-intercept, we will put y is equal to 0. So this equation will become 5 into cos of 2x plus 2. We know that at x-axis y is always equal to 0, so we have substituted y is equal to 0. So cos 2x will be equal to minus 2 over 5, and 2x will be equal to cos inverse of 2 over 5, and 2x will be equal to, if you take cos inverse of 2 over 5, we will have, if we take cos inverse of minus 2 over 5, we will have 113. And we know this conversion that cos 360 minus theta is equal to cos theta, because along 360 we will not have change in function, and 360 minus theta is in fourth quadrant, and in fourth quadrant cos theta is positive. So we can subtract 113 from 360, we will have 247. So x will be equal to 113 over 2, that will be equal to 57 degree, and 247 over 2, this will be equal to, we can calculate using calculator, 247 over 2, that will be equal to 123.5. So basically these are x coordinates of these two functions, and we can also find y coordinates using these equations. So at 57 degree, y will be equal to 5 into cos 57, 5 into cos 57 multiplied by 2, because it is 2x plus 2, that will be equal to minus 0.03. If we substitute 5 into cos 2 multiplied by 57 plus 2, we can find the value of y coordinate. Similarly, if we substitute 123.5 in this equation, 123.5 in this equation, 5 into cos of 2x plus 2, we can have value of y coordinate of this function. And if you talk about next part, we need to equate the value, we need to equate both equations. Basically in second part, part B, we need to find coordinates of P and Q. That will be our second part. Okay, we are supposed to find point P and point Q, which is point of intersection of both equations. So we need to equate these two equations. 5 cos 2x plus 2 will be equal to cos x, and we know that cos 2x is equal to cos square x minus sin square x plus 2 is equal to cos of x. So, and we also know that sin square x plus cos square x is always equal to 1. So this will become 5 cos square x minus 5 plus 5 cos square x plus 2 is equal to cos x. So finally we will have 5 plus 5, 10 cos square x minus cos x, and minus 5 plus 2, that will be equal to minus 3. We have a quadratic equation in terms of cos, and if we solve the quadratic equation, this will become, let's suppose a is equal to cos of x, so that will become 10a square minus a minus 3 is equal to 0. This is a quadratic equation, and we can have two roots of this quadratic equation. We all know that how to solve a quadratic equation. That will be equal to, a will be equal to 3 over 5, that will be our first root, and then b, this is a1, this is first root, and then second root will be equal to minus 1 over 2. You know that we have substituted a is equal to cos of x, so cos of x will be equal to 3 over 5, and here cos of x will be equal to minus 1 over 2. And if we take cos inverse of 3 over 5, we will have x is equal to 53.1, and similarly here x will be equal to 120 if we take cos inverse. Now we can find, this is basically x coordinate of this point, we can find y coordinate by substituting x in this equation or into this equation. You know that cos 53.1 is equal to 0.6, so this coordinate, the coordinates of point A will be 53.1 into 0.6, and similarly we can find the coordinates of q, because here x is 120, so cos of 120 will be equal to minus 1, it is almost equal to minus 0.5. So that will be coordinates of point P and point Q.